Hi folks, welcome to the second video in your 9.3 lecture series. And in this one, we're actually gonna look at the procedure on how to solve a first order linear differential equation and solve one example together, okay? So let me see if I can get this on one screen, but here we have our procedure. This might not be a bad thing to screenshot, so you can have this procedure off to the side as we work through our steps, okay? But let's read through them first. So step number one, we have to make sure that we write our equation in standard form, okay? If we don't do this step, the rest of the steps aren't really going to make any sense, okay? So first things first, we're going to make sure that we write our equation in standard form. Second thing, we are going to compute what we call the integrating factor. We're going to use the letter I of x to talk about an integrating factor, okay? Step three, we're going to multiply both sides of the equation by the integrating factor. Then we're going to integrate both sides. At this stage, this is when we're going to start to see that product rule we talked about in the other video. The product rule is going to be super helpful in steps 3 and 4. Okay? Last step, we're going to solve for y to get a general solution for our first order linear differential equation. All right, let's try it out. So, example number 3 says solve the differential equation y prime plus 4 over xy equals x. Now, I'm going to go ahead and write down step number 1 and the form that we're trying to match it to. So standard form is y prime plus f of x times y equals g of x, right? Now, if we look at this, what we have already is in standard form, okay? So we wrote y prime plus 4 over xy equals x. So let's do a little color coding here. My f of x is the 4 over x. And my g of x is my x. Okay, so do we kind of see how everything is lining up here? Sometimes, like in the later examples, we're going to have to do a little bit more algebra to get to this step. But for the first one, I thought it would be great to just make sure we kind of know what it is that we're looking for. Okay. All right, so step number 2. Step number 2 is where we find our integrating factor. And if you look at your screenshot or scroll back up, that is where we have e to the integral of f of x dx. Okay, so let's try and find our integrating factor. I of x equals e to the integral of 4 over x dx. Okay, so I know that my f of x is 4 over x, so I just make that substitution in there. Now this is going to require me to do an integral. So I of x equals e to the 4 natural log of x. Okay, and that is our integral. And this is really great because we can use some log properties here to help us rewrite this in a simpler way, okay? In fact, we can write this as e times natural log of x to the 4th. So this coefficient comes up as a power. And then this is really great because e and natural log cancel out, and we end up with just x to the 4th. All right, now what this means is our integrating factor is x to the 4th. All right, so we found our integrating factor, and now we get to go on to step 3, okay? Now again, remember I said step 3 and 4 is where we're gonna figure out why we talked about the product rule in video number 1. So in step number 3, we're gonna multiply by our integrating factor, okay? So I'm going to write my equation again. I'm going to take my x to the 4th, which is my integrating factor, and I'm going to multiply it by my original equation. Y prime plus 4 over xy equals x. Okay, so I take my original differential equation in standard form, I multiply it by my integrating factor. Now I'm going to go ahead and distribute. So I get x to the fourth y prime plus x to the fourth times 4 over xy equals x to the fourth times x. So I've just gone ahead and distributed that to the three terms there. Now, before I do anything else, I'm going to clean this up a little bit and see what we get. X to the fourth y prime plus 4x cubed, because I have x to the fourth divided by x, which gives me x to the third. There's still a y there. And then over here, x to the fourth times x gives me x to the fifth. Okay? This is the moment why we were talking about the product rule. So let's look at this. On the left-hand side, I've got a u and a du. And I've got a v and a dv, which means that the left-hand side is the derivative of some product, okay? In other words, this can be written as the derivative of x to the fourth times y. And that is going to still equal my x to the fifth, okay? All right, let's go to step number 4, okay? So we've used the product rule to rewrite that left-hand side and shorten it. Step number 4 says we integrate both sides. So that means I'm going to integrate the derivative of x to the fourth times y, and I'm going to integrate the x to the fifth dx, okay? Cool calculus moment here. The integral of a derivative means you just get x to the fourth y. X to the fourth y equals, all right, now let's integrate the right-hand side. X to the sixth over 6 plus c. We're in our home stretch. We're going to isolate y as our solution. So all I got to do, divide that x to the fourth over, and I get y equals x to the sixth over 6x to the fourth plus c over x to the fourth. Now let me clean that up a little bit. I get y equals x squared over 6 plus c over x to the fourth. And this is the solution I arrive at using the integrating factor and ultimately the product rule to cleverly rewrite things and solve a first order linear differential equation. Okay, so come on back in the video part 3. We'll go through 2 more examples so we can really get the hang of this. All right, I'll see you back.